I'll shake your hand afterwards. No problem. Thank you for having me. I appreciate it. I've always wanted to get up to Temecula. I heard it's beautiful. I work at North Island at the naval base down there. And, you know, everybody's told me how beautiful it is in Temecula. A lot of people are. And so this was a nice chance for me. I like to speak. It's not an effort. I don't have a hard time with it. I'll tell you a little bit about me. I got my bachelor's in computer engineering a couple of years back, and they sent me to school and got my master's in leadership at the University of San Diego. The executive leadership program at USD is a little bit different than an executive MBA that you would get at any other school because it's co-founded by Ken Blanchard. If you've heard of Stephen Covey, Ken Blanchard was a one-minute manager. So this is why I'm mixing leadership with quality. These are two passions for me, okay? So when we start here, our company is here. And the method I'm going to use tonight, I'm not going to try to embarrass anybody or put anybody on the spot, but there's four ways we learn. Four ways we learn, right? There's audible, there's visual, there's touch, and then there's emotion, okay? So I'm going to try to pull you in, all right? I want you to have an emotional bond with what I'm saying to you tonight because you will remember it forever. I do, all right? If I'm successful, everybody will leave here and they will remember this lecture. And I'm hoping you will remember this lecture because of what I brought in this bag, okay? The very first thing we're going to do is we're going to talk about Lean, Six Sigma, and the theory of constraints on the very simplest of levels. Our company is here. Our shop, our branch, division, this factory, this region, whatever, we're here. Anybody want to tell me where our goal is? Our goal. Where could that be? Exactly. Give me, tell me when I'm hot. Oh, let's go here. I can't go above. Here's our goals. All right? Here, I need to ask, where do we put our vision? Where's our vision?
Vision beyond the goal.
Exactly. Very good. Beyond the goal. Because the goal is a step to getting to the vision, right? We want to be the best. Here's our vision. We want to be the best. And we're going to chunk that goal down into steps. Little goals, right? Or I should say vision. We're going to chunk it down into goals. All right? What's one way we're going to get there? That's one way we're going to get to our goal.
Reduce waste.
What does black belt do?
Reduce variation.
Right? So we're going to do
quality.
Lean, Six Sigma, and the theory of constraints. Everybody know what Lean is? What's Lean?
Reducing, well, basically reducing variation, streamlining processes, making them simpler.
Okay, well let's go with the simplest thing. How many military folks do I have here? Prior military? Tony and me. Okay, we're outnumbered, but we can take them, Tony. All right, place for everything, everything in its place. That's the way I like to say Lean, okay? You've got the shop organized, you've got it dress right dress. What's the leanest office you've ever seen in your life? An office where there's millions of files, and somebody goes and gets a file and comes back like that. Doctor's office, right? Okay, doctor's office. The leanest place I've ever seen in my life. They can go in, you've got thousands of folders up there, they go in, phone. Here you are, Mr. Snook, here's your folder. Right? They got your x-rays in there, they got everything in there. X-rays are in a certain place, okay? Because remember, again, this lecture is on how does the Lean Six Sigma theory of constraints apply to the maintenance shop, and how does it apply to any other production support shop, okay? We'll get there in a bit after we get finished defining our items here. So now we have a visual of Lean, which is a doctor's office, right? Six Sigma. Here's where we shrink the variation, right? How do we shrink variation in a maintenance shop? How the hell do you do that?
First, you gotta measure something.
Got to standardize processes.
Standardized processes. What else can you standardize?
Monitor, outputs.
Okay? My task was I had 87 people, 14 different trades, different numbers of people in every trade, 1 painter, 6 carpenters, 14 maintenance mechanics. I had electronics technicians, electricians. What the heck do I do with 87 people? How do you standardize people in all these different trades?
Look for similar characteristics between each of them.
I built my house of quality. I was doing good. You know what he gave me? Zippity-doo-dah. I had a mentor. I had a gentleman at the base that helped me out quite a bit. He says, Frank, you know what? You can't do that. He says, they're not the same. Stop trying to make them the same. So I took each of the 14 trades and I treated them individually. So again, I'm looking for Six Sigma. Fred, how can I standardize, reduce the variation of the maintenance shop? First of all, a maintenance shop, a doctor's office, insurance company. Does Lean Six Sigma and theory constraints apply? Do they apply to that?
I'm sure they can, it's just figuring out how.
Yes or no?
Yes.
Let's vote. Everybody say yes? Raise your hand, please. Come on, come on. Yes or no, Fred? Don't sit the fence on me, buddy. All right. All right. So yes, it applies. Why? What does it produce?
Variation of both of those.
What do those items produce? See, this is one of my big problems too. I thought the maintenance shop produced fixed machines. I've been working in maintenance my whole life, 27 years. I couldn't have been farther from the truth. It wasn't until I walked into the doctor's office I figured out what the heck we produce. Walk in your maintenance shop. What have you got laying all over the place?
Parts?
No.
Oh,
Not if you got it lean, right? You got a messy shop? Your fault.
This is paperwork?
Paperwork. We produce paperwork. 27 years. I'm sitting there saying, no way. Really? That's the secret to success? The trouble call desk rings. My trouble call manual is 33 pages. For the desk operator, for the phone, for 10,000 pieces of equipment in 88 buildings. We've got a 33-page manual for the trouble desk operator. Procedure covers bomb threats, flood, fire, you name it, because that's exactly what it is. When people call, they've got a problem that they need fixed right now. So that's the start point of my process flow, is when the trouble call desk phone rings. Right? And it ends when the paperwork is done. Okay? That's how my carpenters, that's how my maintenance mechs, my electronics technicians, my electricians, my engineers, that's what they have in common. They have paperwork. Okay? So now I can analyze my process and take the deviation out of my process on the paperwork side. Okay? And on the material side. Okay? That's where a maintenance and reliability I might have to stock something else, but I stock 4 foot. I've got 1,000. Right? I've leaned my process out. I stack enough boxes that equate to 1,000 light bulbs. I measure where there's 300. I paint a line on the floor because I stack all the boxes vertically. Right? Hit that red line. What's the red line? Reorder. Outstanding. Look at all the supply guys I got in here, huh? How much intelligence does it take to say, if you can see the red line, take the little tag off, hand it to supply clerk on your way out, and reorder my parts?
Interesting.
Lean and Six Sigma have been covered. Okay? Six Sigma applies to the process, the paperwork process. Remove the variation. Six Sigma applies big time to my material. I get Honeywell UDC 2500 controllers. I can put those in over 500 machines out of the 10,000, maybe more. Haven't gotten there yet. They take universal inputs, thermocouple, RTD, 0 to 5 volts, 0 to 10 volts, 4 to 20 milliamps. All I have to do is program the input and program the output. I'm done. Okay? We buy them all the same kind. We buy them with an infrared port on the front so that I can upload the program. And we pull it down. After we've got it working, store it. And to replace the instrument, we undo a screw, pull it out, put a new one in. It takes about 5 minutes to do a change out, and another 5 minutes to upload the program for a handheld PDA using infrared port right in the controller. When we do this, we can start tomorrow. Draw the line in the sand, just say from now on, here's how we're going to do light bulbs. We took out all the O-rings. We went to Viton O-rings. We get 5 times the life out of Viton O-rings. Okay. We got rid of high-speed stainless steel drills. Went to cobalt. We get about 4 or 5 times the life out of cobalt drills. And they can be resharpened. They cost more? Yeah. Is it worth it? Yeah. Yeah. Okay, so that's how we standardize the process in the maintenance shop. But the paperwork works for everything. How about lean in an engineering office? How can we lean the engineering office?
Actually, before you ask that question, what if you work for a company that has serious budget constraints and they are not willing to buy a lot of parts?
Oh, so are you kidding me? I've got 80-day turnaround time if I process the paperwork today. You got more problems than me? Let's talk. I'll buy the beer. We can cry on each other's shoulders. But let me tell you something. Well, you can sell it to them. Okay? What's it worth that machine being down? In my machine shop, when the machine goes down, and this is pretty universal because I just came back from South Carolina, it's about $1,500 an hour as a good round rule of thumb when the machines are running, producing product. Okay? So you're going to spend, maybe for the UDC 2500s, we spend about $300 more than we would on another instrument. But we can do change-outs in 5 minutes. How valuable is that to your boss?
Well, to your current boss, I think it will make more sense, but for upper management who are closely watching the dollar that you're spending, then that can be a problem.
Who's not watching the dollars? Who's not watching the dollars? You're right. You know, and I got mad with my engineering professors at San Diego State. I said, you know what? So you guys screwed up. They said, why? I said, because you didn't include in the curriculum Begging for Money 101. I said, engineers have got all these great ideas. We know what we're doing, and you got some damn manager in the way screwing up the process, right? But begging for money is always a problem. The thing is, you got to show them the return on investment, okay? So one of the things that they do, another company I know, GPLI, I just went to them in South Carolina first week of March. They said, we have a new process. It is not, it's process improvement. It's very similar to what we're talking about. And what's the return on investment on a black belt project? Anybody know? What's the target return on investment? $100,000. $100,000. If I set up a program where I have him as a black belt student. I'm going to teach him Lean Six Sigma black belt. You're the boss, okay? You're going to rate him. I'm going to train him. You're going to tell me if he's doing a good job. Would you pay me $15,000 to get a $100,000 return on investment?
It's 15 plus a salary, but yeah.
You really.
But yes.
We'll talk afterwards. You're right, it is 15 plus a salary. Are you not going to pay him?
Yeah, so.
Is it worth it to you?
So we could put a company that has laid off a lot of people in the last year. So,
But the turnaround side, right, is
If it's financially justified, yeah, absolutely.
most definitely, right? You're at least going to think now, right? It's not a bad deal.
Yeah.
Theory constraints. We got supply. Right? We got production. What else do we have? Give me one more. Something, the product is going from A to B.
is there a manufacturing process or inspection?
Packaging.
Okay. So packaging, I like that. We'll put packaging because that's towards the end. Right? Production. Here's our incoming supply, right? Also